Okay, I do want to take a couple minutes and just review the properties one more time and show you how we can use them to solve different types of problems. So let's talk about some properties. Remember that we were saying at the end of last class that we had this theorem, and the theorem was if f is continuous, on the interval AB, then the integral from a to b of f of x dx exists, meaning we can find the area. Okay? So the properties that go with that, and we talked about these briefly yesterday, but just to refresh, the first property is that if I'm evaluating the area at a point, that would just be 0, right? Because a point has no breadth and no depth, so we can't actually take the area of it. We also had if the area from b to a is f of x dx, that, pardon me, I flipped that around, that would be the negative of the original area. Excuse me. And you'll see how these come into play as we go through some different problems. We also have the interval from a to b of some constant k times f of x dx. And we can take out that constant and then evaluate the integral of f of x dx. We also talked about the sum or the difference. So I'll actually write it as 1. So f of x plus or minus g of x dx is equal to the interval from a to b excuse me, of f of x plus or minus the interval from a to b of g of x. Next we have the additive property. And the additive property says that from a to b, if I have f of x dx, I can actually break it up. So I have a to c of f of x dx plus c to b of f of x dx. Right? And we had we just had a rough sketch of that, right? If here's our function and here is a, and out here is b, and c is in here, then we're just taking this area and then this area and then adding them together. Okay, so there's one other one that we didn't talk about that I do want to talk about, and it actually is going to be really helpful. If I have the interval from a to b of a constant, so k dx, that's the same as saying k times b minus a. And we sort of talked about it when we did the area under the horizontal line, which gave us the rectangle, but that's the actual property that goes along with that. Okay? And so why are these important? Well, let me show you how we would use these in an example problem. So let's say, suppose f and g are continuous. And that we've got from 1 to 2 f of x dx is -4. From 1 to 5, f of x dx is 6. And from 1 to 5, g of x dx is 8. Okay, so those are our given conditions. We're going to find a couple of different things. So let's start with the first part, from 2 to 2, g of x dx. Well, that's an easy one. That goes back to our first property here, right? Because we're just finding the area under a point. Can't do that. We would just get 0 for that. So that's pretty straightforward. How about if we have something like this, where we're going from 2 to 5 of f of x dx. Do this in another color. Well, I don't have as my choices from 2 to 5. However, I do have from 1 to 2 and from 1 to 5. Right, so I can actually break this up using our property down here about different parts. So let me show you what I mean by that. I can actually do this as, if I look at this as from 1 to 2, because I have from 1 to 2 of f of x dx, and from 2 to 5, right, of f of x dx, that would have to equal from 1 to 6, right? Oh, sorry, from 1 to 5. Not 1 to 6, from 1 to 5 of f of x dx. 1 to 5, excuse me, of f of x dx. Okay, so I'm taking a couple of different parts I have here. Right? I'm using this idea of property number 5 here, where I can do it as the additive property. And so I know from 1 to 2 that this is -4, right? I know that from my given conditions. This is what I'm trying to find. 5 f of x dx. And I know that from 1 to 5, that is equal to 8. Oops, sorry, I'm looking at the wrong one. That's actually equal to 6, not 8. This one right here is equal to 6. And so if I solve that, right, if I add 4 to both sides, I end up with f of x dx from 2 to 5 would have to be 10. Okay, so it's a very easy property to utilize, but I did want to go through that one in particular. Let's go through kind of another idea here. Using those same parameters that we had up here, let's try this one. If I have from 1 to 5, 4 times f of x minus 5 times g of x dx. Okay, so if I go back to my properties here, right, I can take out that constant. So I have a constant here and a constant here, so I can take those out. And I'm also using property number 4, where I'm taking the difference. So I'm kind of combining two different properties here into a single problem. And so I can rewrite this as 4 times the integral 1 to 5 of f of x dx minus 5 times the interval from 1 to 5 of g of x dx. And f of x dx from 1 to 5 was 6, and g of x was 8. So I have 4 times 6 minus 5 times 8. So it'd be 24 minus 40, and that would give me then negative 16. Okay, and then the last one I want to go over is the idea of, for the interval from 1 to 5, of f of x plus 3 dx. Okay, again, I can break that up, so I would have from 1 to 5 of f of x dx plus from 1 to 5 of 3 dx. Okay, so I know this first part, we were given that information, that's just 6. This last part here falls under this last property down here. This last property down here where you're just taking a constant, the integral of a constant. Okay, so I can use that as well. And so when I do that, I have the constant 3 times b minus a, or 5 minus 1. So that gives me 6 plus, that'd be 3 times 4 is 12, so my final answer there is 18. Okay. So that's just one other way that we can use those properties given certain conditions. I did want to go through that just so you can see how that works. Okay, hopefully that'll help you with the assignment tonight. Thanks.